Carbon. Carbon's atomic symbol is C. At the top, we write the mass number. So this is the mass number. And then on the bottom, we write the number of neutrons that there are. And for carbon, it's not neutrons, sorry, protons there are. And for carbon, there are 6. So this is number of protons, or if you remember, this is also called the atomic number. This is what every isotope of the most abundant isotope of carbon looks like. So what is an isotope? Isotopes are different atomic forms of the same element. So for instance, carbon, so its number of protons usually stays the same. But then in an isotope, then the mass number could change. It could be 13, carbon 13. It could be carbon 14. Or it could be, which is probably really rare, carbon 11. These are different isotopes of the same element. What that means is that if we look in our nucleus, we have the same number of protons. So imagine the pink are the protons, so 4, 5, 6. And then the number of neutrons, 1, 2, 3, 4, 5, 6. And then we have our electron cloud around, and our second one around, like that. If we just imagine it that way, this being our neutron and this being our proton. If we see that, the 13 that we got here, the 11, the 14, or the 12. So right now this one is carbon 12-6, which means that there are 12, basically 12 things in the middle. We have 6 neutrons plus the 6 protons, which gives the 12 that we get as our mass number in the middle. This is our mass number. What if we added another blue or a neutron? Now we have C6 and then it would be 13. Because if we look here, we have 7 neutrons plus 6, which is equal to 13, which is now the mass number of this. And the number of protons stays the same. So we could say that 12 is pretty stable. 13 is pretty stable, I guess. But this is a pretty rare isotope here. This has 8 neutrons. And because it has so many neutrons in its nucleus, it becomes unstable. And also something we call radioactive. What radioactive means is that it likes to shoot out its neutrons. The neutrons are shot out, or basically it destabilizes, and different atoms are like poo from the center, so it goes because it's really unstable. And that instability is what causes radiation from the isotopes. I probably spelled it wrong. That comes off of the isotopes. Now so we call these type of things radioactive isotopes. We don't call this one radioactive, no. We don't call this one or this one, but we call that one radioactive. Radioactives can be useful for research in medicine because radiation from decaying isotopes also can be used as a tracer. Like, let's say you have a cancer and we want to figure out where it is. So they will attach a so let's say this is a radioactive isotope. They'll attach it to a molecule that might be used in a certain place where they think that this will be used for your cancer cell division. And then it will be tracked along, and then I was like, oh, it's in your throat. Ooh. And then they'll say, okay, here is where your cancer is. And then they could treat it later. And to use this, you use a PET that scans for these radioactive. So you could say like, oh, this is a cancerous throat tissue. I just abbreviate it. I don't want to write it all out. And this is basically what isotopes are.